Now that we've gone over the core of my geometric Voronoi cutter workflow, let's take a look at art directing our fractures a little bit more. So, as we discussed at the end of the last video, our initial results from our fracture give us one big, thick concrete slab. And this is not what we would want. We wouldn't expect the entire helipad to be composed of one homogeneous, big, huge concrete chunk. So, before we fracture this, we should hollow out the insides of this to give it a top and bottom. Now, there are a couple different ways of doing this. If you go into the fracture object, let's pull our helipad geo off to the side a little bit and start looking at a couple of our options to cut this up. Now, one thing you notice when you put the display flag on this is that the helipad shot off somewhere else into space. That's because when we were debugging our weird fracture results, we scaled down the geometry and the cutters, since working at a huge scale was pretty problematic. And we did that scaling down within our fracture setup here. So let's move this transformation out of the fracture setup, and let's put it outside of that on the inputs that are going into the fracture. So we can delete out the cutter transform node, and we'll cut out the input geo transform node. And let's instead place that on our geometry right after it's converted to polygons. And we'll do the same to these cutters here. So now if we display that transform, our helipad will be back in the space we expect it, and we don't have much visual reference for that, but the spreadsheet shows it's at 3,000 instead of 32,000. And the same thing with the cutters, those are now in the same space as well. Now, in order to hollow out this geometry, one of my favorite methods for doing this sort of thing is to use the cookie operation. Now, cookie operations have a bad reputation in most 3D softwares, really, not just Houdini. And they have a bad reputation for a pretty good reason. They tend to be pretty finicky and unstable, and very sensitive to the input geometry you're feeding into them. It can't handle very complex geometry. You can only get reliable results out of pretty basic shapes. But in this case, that's just fine. We don't need to do very complex cuts to break this into a few large chunks for fracturing. So let's start by dropping in a grid node. And we'll drop in our cookie node as well. We'll hook up the helipad into the first input. And before we hook the grid up into this, let's make it the correct size and position first. So let's Control-click to template our grid there. Then if we select the grid and then use our Houdini manipulator tool here, this gives us slightly different controls depending on what object you have selected. But for some of the basic geometry, it's pretty nice. This will let us drag the sides of our grid out like so. So that we can quickly get it into about the right position. Great, that gets us pretty close. Now if we zoom in, we're going to put this cutter plane just underneath that ridge there. We don't want it to touch the ridge because that's something we don't want to cut. We want to keep this top section as one slab, same thing with the bottom, and isolate just the middle section. So looks like we're probably just close enough without actually cutting into that ridge. We'll lower this down just a tiny bit to be safe, and that should do pretty well. It doesn't have to be totally perfect for our purposes. Now if we pipe our grid into the cookie operation, let's check out the results of that. So by default, you'll see it's isolating the top slab, and it'll also include the cutter plane as well. So we'll have to play around with our cookie options to get to isolate just this top slab without including the bottom whatsoever. Now, if you look at the cookie operation, it's defaulting to union, which is going to give us some combination of the two. And if we change this from union to intersect, then that will give us just the bottom section, which is a step in the right direction. But if we only want the top section, we'll have to make a little bit of a change here. There are a couple different ways to do it. But one way that I like to give us the opposite side of this cookie is to change the direction of the polygon surface. Now, one way to change the direction of a poly surface is to reverse the winding order of the polygons, and that's an option available to us in our clean node. It might not be one of the first things that you think of to change the direction of a surface, but it can be pretty effective to do that. So if we drop a clean node under our grid, by default we won't see the change we're looking for, but if we turn on reverse winding, you'll see that that will change the direction of this grid surface and give us the opposite result from that cookie. Now, to get the bottom surface, let's take this very same grid plane and we'll move it off to the side here, and we'll connect that to a new cookie node. That going into the second input once again, and our helipad into the first input. Once again, we're defaulted to a union operation, and we'll change that to intersect. Because this grid isn't being sent through a clean node to reverse the winding order on those polygons, we're going to get the original surface below the cutter plane instead of above. So you can see the difference here. And in order to isolate just the bottom slab, let's drop a simple transform node on this grid here, and we'll lower this down. Since it's pretty simple geometry, you can see that cut interactively. You can tell we've gone too far there, and we're cutting into the ridge. So that gets us pretty close without cutting into the ridge, and this should work out pretty well for us. So now the one missing piece that we still have to cut out is the middle section. Now, to cut out that section, we'll use the same grid inputs to keep everything nice and clean and make it sure that it all matches up. So let's drop another cookie node here. Once again, we'll grab our input from our helipad, and let's connect the transform into this and see what the output is once we set that to intersect. So for this surface, we'll want the inverse of what we have right now. So let's, as before, let's drop in a clean node and reverse the winding order on this so that we're only chopping out the bottom section. And we'll take the output of this cookie operation and we'll run another cookie on this here. If we run the output of that cookie into this one, and then attach our original grid to the second input and set this to intersect, this will give us only the middle section. So this node network here is a bit messy. I always try to make sure my node networks are clean just for myself, and also because you never know who else might pick up your work. But sometimes when you're doing this sort of thing, it's hard to avoid it getting a little bit messy, but just try to keep it as neat as possible. And we can also make this a little bit cleaner. We say select all these nodes, and we can create a box around them and call this chop helipad. It'll make it a little bit more obvious what's happening here, and it'll clean up our network a little bit. So now we can look at our various cookie outputs. We've got the top and the bottom and the middle. And actually, let's do one more cut on the middle of this object here. And let's create a cylinder for that. So let's drag this tube node over here to do yet another cookie operation on this middle section. Let's connect this cookie output into that one. And let's take a look at our grid position to use that for the center of our tube. So if you right click and copy the center parameter of the grid, we can paste copied values into the center of this tube here. Now you can use your own judgment as far as how thick you think the wall of this middle section should be, but I think this should get us to a pretty good place. I'm going to add the end caps to this tube, and let's convert that to a polygon and increase the resolution of this a little bit so that we get a bit of a smoother cut. It doesn't have to be perfectly smooth, but yeah, something like this looks like should do pretty well. Now let's pipe that into our cookie operation and look at the results. And we've been using the intersect, but in this particular case that doesn't seem to be our best option. In this case, I think a minus b should work just about right. No, it doesn't. As before, this union operation isn't going to give us quite what we're looking for here. So in this case, we're going to use a minus b. That's the first input, the helipad section, minus the second input, this tube here. So if we do a minus b, and now that looks wrong at first, and this is just another case of, cookies can be a little bit not intuitive to play with sometimes and a little bit finicky, but we can get better results if we assume the input A is closed. And we can assume input B is closed. Now this is a good example of another thing to watch out for with cookie operations, as we're still getting some incorrect results out of this cookie. And the reason for this is usually due to some problems with the input. Just from experience, I know that you have to be careful about the surfaces being closed for this sort of thing. So let's go to our previous cookie operations that we did on this middle section. But you also notice there's a consolidate edges option that we didn't have turned on. So let's select both of these and turn on that consolidate edges. And I wouldn't worry too much about these dark areas. Sometimes when we're doing fracturing and whatnot, we'll have some normal weirdness. That is weirdness with the normals on the object, and we can often fix that just by adding some new vertex normals or something to that effect. But now if we look at the output of our final cookie operation here, this is giving us much more of the result that we were expecting. This is a fully closed surface on the top and bottom and looking much better. So let's add some new normals to this. We just drop in a normal node that's defaulting to vertices, which is probably what we want in most cases. And if you view that, you'll notice that cleans up all the edges pretty nicely. And let's also make this change to our top and bottom sections. So this node looks okay at a glance, but we also should turn on consolidate edges for this one. And for the other one as well, just to make sure that we're getting nice surfaces when we fracture this. And also just to get a little bit of a more even surface across this, because we're getting some pretty wildly changing topology between tris and quads and etc. Let's just divide everything to triangles. So if we just drop in a divide node, and the default maximum edges of 3 will ensure that we're creating triangles. So if you look here, that'll give us a much nicer mesh. And of course, let's also create some vertex normals on the top and bottom sections as well. So now that we have all of our working pieces, let's try fracturing some of these. Before we run each piece into our fracture setup, let's just organize a little bit more by creating null nodes for each of these. So let's call this one out middle, and let's copy that and connect this one, which is going to be bottom, and one more null called out top. Now let's start with our top node, and let's find our fracture setup, and let's drag this down to the top null. We can take this out top and pipe that into our fracture setup here. And now let's check out the output of this. Now our top section fracture looks pretty good. Looks like the same results that we were getting from the fracture of the entire piece, just skinnier as expected. So now we can copy the same fracture subnet for the other two sections, and then let's see what that output looks like. Okay, the other two fractures have finished processing now, so let's check out that output. This bottom piece looks very similar to the top section. We're feeding in the same cutter geometry, so we'd expect those to be pretty similar. When you go in and add some more cutter geometry, you can certainly feel free to add some separate cutters that only intersect the top or the bottom. That's up to your artistic judgment. And then this middle piece doesn't have a lot going through it in terms of cutter planes, but that's been segmented as well. Let's a couple small changes. Right now these fracture setups are exporting the exploded view. We want this to always export just the Voronoi fracture itself. So let's change the display flag within that subnet to the Voronoi fracture node for all three of these. And then let's do a simple merge on all of them. We select all three and merge them together. And now that we have everything together, let's drop another exploded view out here so we can see how all the pieces fit together. So this is a decent first pass and working example at fracturing up this object. Obviously you're going to want to go and start manually art directing some of the cuts in here. We'll also want to scale down the robot and the rest of the tower and the camera and such to match our scaled down scene. So one way to do that is if we create a new geometry node up top. Let's call this scale parent. We can simply parent some of these other objects to that. So if we set the scale of this scale parent to 0.1, we can connect the robot to that, and you'll see the robot snaps down to this same 1/10 scale. And if we visualize our tower, it's super in the way right now. I won't zoom back to illustrate that, but when we connect that, that's scaled down as well. We can do the same thing with our background buildings. And finally, with the tower animation piece. Let's also not forget our camera, since we'll need to view our scaled down scene in the correct camera view. So let's move all of this up. So now if you look through that render cam, you'll notice that that's been scaled down with everything else. So for this week's homework assignment, you're going to be fracturing up some of the assets in this tower. The main thing, of course, is this helipad here, but we'll also need some fractures, at least on the top sections of these support beams here. You'll want to look at the render cam at the end frame to see how much is going to be in view, because we'll want to have at least a little bit of these fractured supports visible to add some visual interest to the shot. But I'd also like to leave you with a couple notes on tweaking this fracture. If you find that these large chunks of the helipad are stuck together and they're not actually split by these cutter planes, you may need either more points along the cutter planes, or you may need to increase the distance that it's scattering points for these large chunk defining areas. So yeah, you'll play around with the scatter points. Less will be faster, of course, and more will give you more detailed results. You can also increase the number of secondary scatter points along the cutter planes. Those are the ones that got unique cluster values that were transferred onto the actual cutter points. I believe we scattered about 100 along these cutter planes that then transferred their cluster value to the actual cutter points. If you scatter some more in there, you'll get smaller pieces. And it's up to you to play around with largely the scatter points, the distance here, and of course where those fracture lines will be. You may also find that when scrubbing around in the timeline that Houdini will want to recook your fractures as you scrub. It doesn't really make much sense because our fracture shouldn't be time dependent, but there's a simple fix for that in most cases. If you drop down a time shift node, we're at frame 1010 right now, and you set the frame on the time shift to the current frame, just the hard value, not the frame variable. You should then be able to scrub around your timeline, because I was having problems where every time I tried to scrub to see this in the render cam, it would be trying to recook these fractures, which could be a little bit frustrating if you're trying to see this at different angles in the actual shot. So for the homework assignment, I'd like you to include a few images, could be anywhere from, let's say, 3 to 10 images that will illustrate where you're at with the fracture on this object. We'd like to include the wireframe, obviously, and it would be helpful to include at least one smooth shaded and not wireframe. And you can optionally also include a playblast or a flipbook from the render cam as well. Of course, if you run into any problems or have any questions, you can feel free to contact me and use the forum on the website. And also, throughout the course, we're going to be set dressing this tower so it's a little bit more interesting than just the helipad. So at any point from week to week, if you want to add any extra props, whether it's railings or, I don't know, cargo boxes or any other props that you'd like, maybe some stray pipes laying anywhere, you can take it upon yourself to gradually increase the set dressed level of detail that way. Not required for this first week, but you can start putting some thought into what sort of props you might like to add to this. And I'm looking forward to seeing what sort of ideas you have and how your fractures turn out.